Okay, so this is a video to help you out with, now that you have your housing data, to help you out with how to actually see something from that data using R. So you should have downloaded RStudio already. You should have watched the tutorial, which will help you. But you can also follow along with my video here to go through the housing data questions. So first, you're going to have these little console or these windows when you open up RStudio. This window here with the numbers labeled is your R script. It's where your code goes. Here we have the console. If you look at videos on R, you sometimes see people working on the console. It's actually not a good idea. It's like doing everything in the front entrance of your house, so not a good idea. Over here, you're going to see data. We're going to actually look at this every once in a while. And over here, you'll be able to see the plots. You can also go to help. If you need, they have great help browsers and so forth. The very first thing you'll want to do is go into your RScript editor part, this top part, and then you'll go to session and set that working directory to wherever your data is. So in my case, the data is in teaching, 216, in this folder here. So now that I've got to that folder, I'm going to open, and what you'll see down here is the set WD, this teaching. You don't have to put this line below here, but I would, to make the document at the end, you need that line in there. So you could copy and paste that line and put it here for later. You won't need it right away. The next thing you need to do is upload or install the packages you'll need. So this is different than Mathematica, which is probably something you've used before. Mathematica is an expensive piece of software where most of the packages that you would need are already built in. That's why it's expensive. They have programmers that have made all that for you. Here, the way R works, it's free, and it's what we call shareware, so people can use it, and people can contribute to it. So these packages, like TidyVerse and gpub R and ggplot2, are made by people, and they are not part of the regular R script, and you do need to document that you use them. So the first step to upload those packages, because they're not all there for uses, the very first time you use it, you have to put this command in, install.packages TidyVerse, in quotes. I don't have to do it anymore. In fact, it's going to scream at me if I do it. Now, Control-Enter is how you get it to execute that line. And right now it's going to, well, I guess it's, yeah, okay. So it screamed at me here in the console. I see the output. It said, oh, so it actually downloaded it, but I didn't need to download it. You only need that for the very first time. I don't need it anymore because I've already downloaded these files in. All right, so then after you do install for every single one of these, library, ggpub, so these are all the packages. So I'm going to put a little comment here. These are the packages I use. Remember to so that's just a reminder to you. But now I have to do Control-Enter on all of these libraries. So it's uploading these libraries, and I have to do this every single time that I use these packages. So just to make you understand, like if you're using the plot command or plot3 command in Mathematica, somebody's built that package, it's a programmer at Mathematica, and they put it together so that you don't have to upload it. There's no inconvenience. This is the inconvenience, but it's well worth the trouble. So I did Control-Enter, and you see that I got output from here. And that's just it. It's just loading up these libraries for my use. The next step is I want to read data, and this is what I mean by commenting. So this particular code I got from when I taught 376, I commented it well, so I could actually just change a few things for you. So recall that I downloaded Spokane data because that was the closest city to Glendive, Montana that existed on Redfin. It's already in my files. So I'm going to now read that data. So this is the command to read a CSV file. If you saved it as an Excel file, that's not going to work. You have to save it as a CSV file. And so I'm going to call that file data. I'm not very original. And I call it exactly the way it is in the folder. So let me see if I have a copy in the folder. So there it is, Spokane. If I do properties of that file, it's a CSV file. It says it, and the name is Spokane, spokane.csv. Now, if I do something incorrect, like I put a capital S up here, what you'll get, and Control Enter, well, I don't know why it read it, it's not there. So that's the file I want to read. Let's say I forgot the file name and I put like something else here. It'll give you this error. It cannot open the file, no such file or directory. So sometimes I have to go back and look in my directory to remember what I called the line, or if I'm clever enough that day, I'll copy and paste from the properties the name of the file and copy it into here. But let me copy and paste that in there. Now notice that I have this file data. If I click that file data, this is the spreadsheet that you see in Excel. So I can actually see what's there. So I check everything, I double check everything to make sure I have it all. Now, in this file data that you see right next to this housing project file, that's the R code, I notice that there's a lot of these NAs. That's missing data, and it'll appear as NA. I don't want to consider that missing data. I don't want to worry about it. So this command here removes the entire observation, which is the row of missing data. Just for kicks, the rows are the listing of the house. So the observations are the house listing. That's the observation. A variable would be the price of the house. Columns are variables, rows are the observation. So let's remove the missing data from the number of bedrooms. Let's remove the missing data from all of these. Let's just remove them all. All right. Now the first visualization I'm going to show you is one of my favorites. It's not in the R tutorial you just got, but it allows you to see an XY plot. So you're plotting the data. So I'm going to say number of bedrooms is my x-axis and the price of the house is my y-axis. But I also want to see a line going through the averages so I can see the trend. This command jitter allows you to jitter the points so that if they're overlaying each other, they don't look like one massive blob. And I can order a bunch of the data. So there's 1-bedroom houses, 2-bedroom houses, 3-bedroom houses. If you go to data, you'll see in beds, there's all these different types of houses. There's bedrooms, 3-bedroom houses, 4-bedroom houses. So I take these and I want it to just plot in chunks the 1-bedroom house prices, the 2-bedroom house prices, and all separately so I can actually see that trend. And I'm big on the labels being the correct labels. You drop off the labels, that's going to annoy me because I'm grading your stuff. You never want to make me grumpy. And also, it's just good practice. The next time you need it, you have it to grab. So, gave me some warning. I had still rows of missing data. But let's hit zoom over. You see now there's a plot here. If you click zoom, what you'll see is the price of 1-bedroom houses scatter plotted. And the next chunk is 2-bedroom houses, 3-bedroom houses, 4-bedroom, 5-bedroom, 6-bedroom, 7-bedroom. That's the max I had in Spokane. Now what I see here is that as expected, the means, the averages, trend upward the more bedrooms I have in the house. However, once I reach 5, it kind of levels off, it declines, or levels off, however you want to say it. Up here, I see some really expensive houses. I'm a curious person, so I kind of looked at that and went, what's it about this 4-bedroom house that makes it cost so much? Now down here, you'll see these little bars. We're going to talk soon about variation in the data. So here I have a small sample of 6-bedroom houses. There's a lot of, the wider those bars are, the more the variation is in the price. So for now, that's how you have to think of it. So I like to see all that. All right, now I'm going to make scatter plots. So you should have seen that on our tutorial already. ggplot's a command I'm going to use. Data. I'm going to let the x-axis be square feet. Where did I get that from? Well, I just kicked it up, but I got it from here. And I'm going to I think this colon doesn't need to be there. Let's see if it works without that, this apostrophe. And then price. And you have to put this geom point. Geom point tells it to make a dot. I'm just going to do that. And that's just a scatter plot. That's just like what you would do in Excel, making a chart. As expected, your square footage, the higher your square footage is, the more the cost of the house. It looks like it kind of has a little curvilinear trend here. Here again, you see these expensive houses, despite them having the same square footage as these houses over here. Now, what could explain those high housing prices here? Well, maybe they have more bathrooms. So what I'm going to do is I want to see the same picture I saw before with square feet as the x-axis, y being the price, but I'm going to make it color the dots differently for the number of bathrooms. If you go back to this data, you'll see there's 1 bathroom, 2 bathrooms, 3 bathrooms. So I'm just going to give it a different color for every different number of bathrooms. And let's see what happens. Okay. So up here you see this has, I think, 2.5 bathrooms, and it looks expensive still. So that's not the explanation. So it gave me, as expected though, 1 bathroom is at the lower end of prices, and it's also associated with lower square footage. I see them dropping in, 2 bathrooms are here, 3 bathrooms, so they're kind of chunked up together. The only explanation, see, this thing has 5 bathrooms. Somebody bought it because they like the number of bathrooms. This guy here with a 7-bedroom house had 5 bathrooms. So, but here we only have 2.5. It's still an expensive house. All right, let me show you one more thing. I could take this and I could say, okay, maybe it has something to do with being a new versus old house. So I'm going to put year.built. It's one of the columns. So you do have to kind of look in here and see what columns you have. And they do have a column called year built. So maybe this is a newer house. Let's try that. Instead of the number of bathrooms, let's put the year built. We're going to get a mess. Because there's so many years that the houses could be built in. So I look at this, and this graph, well, looks kind of difficult to look at. It looks like there's a trend, but I can't quite see it that well because there's too many colors. Like here, over here, there is like a purplish, so it must be a newer house. But I really have to this is ridiculous looking at this legend. So what I'm going to do is I'm going to coarsen the year built. I had here year built 1990. Let's put it as 2011 or 2000, okay? And if this is a command that will make a new column in your spreadsheet, mutate is the name of the command. I'm going to call that new column date. If else is an if then statement. So if the year built was less than 2000, I'm going to call that an old house. If the year built was not bigger than or equal to 2000, I'm going to call that a new house. So I'm going to control enter on that one. And just let's look over at the data spreadsheet. And if you go over to the very right, you'll see I have now a new column called date where they have everything aggregated by old versus new. All right, so I'm going to plot the same plot I had before, but let's get rid of this shape. You can make shape, well, we could do that. We could make the shapes. You could do color, bathrooms, shape, the date. Okay, let's do that. So you're allowed to use 2. It's like you can see in multi-dimensions now. All right, let's zoom that out. Now we see something. Old houses are triangles, new houses are circles. And the new houses are definitely look like they're up here, and the old houses look like they're down here. But this is an old house. It's an old house with 2.5 baths. I have no idea right now why that might be. I'm getting more curious about this little triangle up here. Okay, you can also look at statistics by group. So I can look at the averages. So let's look at the summary of the command is group by. This little guy here is called the pipe. Percentage greater than percentage. That's called piping. So I'm going to take the data and I'm going to group it by year built. So it's like you're going into, you sorted the years that they were built into groups, and then you're calculating the average of that price in that year. So it'll give you a table full of averages. Let me show you what that looks like. So I called this summary stats. I have a reason for doing that. When I did summary stats, is control to enter on summary stats, this appeared here. There's 94 observations. That means there's 94 rows. I don't know if I can see it. The data looks like this. It has the year built and the average price of the house in 1889. So it gives you averages of over all the houses. Notice it stopped at 84 rows. The quickest way to get all the rows is, well, I know there's 94 rows. I'm going to ask it to print all 94 rows. And now I have all 94. And you can use summary stats now. You can say, okay, I'm going to go back to ggplot. And I'm going to put here, well, actually, that's fine. Let's do this. The old, I'm going to get rid of everything. I'm going to put here summary stats. Let's put here year built. I have no idea what this is going to look like. Make sure that that's how it's calling it. Yep, it is. And here I'm going to put average. For the price, I'm going to put average. So you notice I'm copying and pasting a lot of stuff. Well, that's the whole point. You can, once you've done it once, you copy and paste stuff. All right, let's get rid of this. And let's see what happens. Oh, I have an extra, looking for extra something. I have a parentheses missing. Let's try it again. Let's go up and look. Let's look at this summary stats file. Year built, average. Okay, it looks like it works. All right, so it's done it. There we go. And now I can see the averages of all the housing prices by year. And there is a trend. You see that it looks like the housing price, average housing price of newer homes cost more than older homes. So this is a way to look at your aggregated data in some kind of format that you can see. All right, finally, I want to share all this with someone else, but I don't want to copy and paste this whole thing. So what you can do is you can go up to this text thing where it says compile report and click it. I'm going to compile it as an MS Word file. And it's important that all your code has to work. If there's a line that you leave in there that doesn't work, it's going to scream at you, like it's screaming at me right now. But it still made me the file, and it makes me this nice file at the end that you're going to send to me with your actual work. So I can see everything. I can see that crappy plot where nothing can be shown. I can see these nice ones, and so forth. So it might be, and it also calls it housing projects. Let me just save that into my 206 files. So now I have it saved. Now you're going to save it, send it over to me so that I know and I can rest easy that you know how to do this. All right, so that's your project for today, is to sit there and come up with this file. And by the way, that outlier, I haven't looked at it. It's not, we haven't talked about formal definition of outlier, but they have this one dot that seems to be an old house, 2.5 baths, really expensive. Location is something that we haven't looked at. It might be right on a lake. So that would be my next hunch, is to look at the location.